Joseph is recording. Joseph started recording. He will share. Okay.
Yes, sir.
Pritika.
Sir, if we
Joseph is
record
recording.
we
I am not.
okay, sir.
Okay, ma. I will share it. Don't worry. I will share this class in the form of MP4 video format. Just recording. I am also trying to record in OBS. I am using OBS to record this class. I'm trying differently. I'm trying not to from Google Meet. I'm not recording this class in Google. I'm recording this class using OBS.
Okay, sir.
I'm trying differently. Okay, ma. If it is successful in OBS, this video is recorded in OBS successfully. Continue this process. OBS. Do you know OBS? That is our software. By OBS, I'm trying to record this class. This is the domain of cotangent of all real number minus set of x such that x is equal to a, comma n belongs to z. Range of this cotangent is reverse. See, secant x same as tan x. This is the same as r minus 6 such that x is equal to n plus 1 to pi by 2, comma n belongs to, and the range of cotangent, range secant x, the range of secant x is r minus open interval and one currently domain of cotangent cosecant domain of cosecant x as the cotangent r minus set of all x such that x is equal to n pi, comma n belongs to z, and its range is r minus interval minus 1, comma 1. These are the ranges of trigonometric functions. If you take this one, in case, these are only one two functions. These are not bijective functions. In previous exercise, in the previous chapter, we have discussed only bijective functions, inverses. Only bijective functions are invertible functions. So remember that one. Which type of functions? Which type of function are invertible? My diagram. Which type of functions are equal? Which type of functions are equal? Kiran Raj.
Sir, your voice is breaking, sir.
Okay, which type of functions are invertible? Which type of functions are invertible?
Sir, can't hear your voice, sir.
Grayson? Grayson?
Sir?
Which type of functions are invertible?
Sir, bijective function is invertible, sir.
Bijective functions, sir.
Yes, only bijective functions are invertible. Okay, all these cases, these are all not bijective functions. These are not bijective functions. So to find the inverse of these trigonometric functions, we had to change the domain of these functions. We had to restrict, we have to take some limitations to define inverse of these trigonometric functions. Okay, my children. In all these cases, these are all not bijective functions. Suppose if you take real numbers, let us take a real number line. These are also real numbers. We represented real numbers in terms of pi. These are also said to be real numbers. This is also a real number line. Suppose if you divide this real number line into different intervals like this. Close interval minus pi by 2 to pi by 2. Close interval minus pi by 2 to pi by 2. Similarly, minus pi by 2 minus 3 pi by 2 comma minus pi by 2. Here pi 2 so on. If you divide this real number line into different intervals, in all these intervals, we have divided this total real number line into different intervals, namely minus 3 pi by 2 comma minus pi by 2 close interval, minus pi by 2 comma pi by 2 close interval, pi by comma 3 pi by 2 and so on. If you take these intervals, as domain of sine inverse x, these are all said to be different branches of sine inverse x. Okay, see here. If you take domain of this sine x, in this case, without taking all the real numbers, real numbers in the domain, if you take only this interval, minus pi by 2 comma pi by 2 close interval, 2 close interval minus 1 comma 1. In this case, it is a bijective. Then its inverse. We write this one here as a domain. And this is a range. So like this, suppose if you take this interval, minus 3 pi by 2, in this case also, it is a bijective. If we take only this interval as domain, range is a close interval minus 1 comma 1. In this case also, it is said to be bijective. Then its inverse. This range becomes a domain, and its domain becomes range. Minus 3 pi by 2. In this case also, it is a bijective. So we can find its inverse, sine inverse x. So in all these cases, similarly, if you take pi by 2 comma 3 pi by 2, close interval pi by 2 comma 3 pi by 2. If you take domain as a close interval pi by 2 comma 3 pi by 2, is close interval minus 1 comma 1, then it is bijective. Then we can find its inverse, sine inverse x comes as a domain and it becomes as a range. So we can find infinitely many intervals on this number line. We can divide this number line like this, infinitely many intervals in which sine function is a bijective. So we can find its inverse. But here we take this only, minus pi by 2 comma pi by 2 is said to be principal value branch. All the remaining intervals are said to be branches. In all these cases, so in all these cases, in the interval, first interval is minus 3 pi by 2. Like this intervals, sin x is in all these also sin x is 2. Since it bijective, we can find its inverse function. Fine by children, we can find its inverse. But all these set branches, different branches of sine inverse. These are all said to be different branches of sine inverse. But especially this closed interval minus pi by 2 comma by t is said to be principal value branch. especially this closed interval pi by 2 comma pi by 2 is said to be principal value branch of sine inverse x. Okay, my children, there are two types of branches. All the remaining are said to be branches of sine inverse x, but especially closed interval minus pi comma pi by 2 is said to be principal branch of sine inverse x. Similarly, we define the remaining are trigonometric functions. Here, please note that symbol is written as sine inverse or arc sine x. All of you remember this sentence made. The symbol is read as sine inverse x or cos x. Can you read this sentence one by Joseph?
Sir, your
Joseph?
voice is breaking, sir.
Okay, read this sentence.
Sir,
Read this sentence.
sir, the screen is now very blurred, sir. 1 minute, sir. Let me. Okay, sir. Sine inverse x, sir.
Yes, this is sign. This symbol is read as sine inverse x or cosine x. Okay.
Okay, sir.
Grayson, read this one. This is read as
Sir, it's read as sine inverse of x or arc sinus x, sir.
Celestina. Read this line. Read this line.
Sir, it is read as sine inverse x or arc sine x, sir.
Mr. Kevin, this. My dear Kevin Paul, read this line.
Sir, the screen is not clear, sir.
My dear Kevin Paul, read it. Raj.
Yes, sir.
Can you read this one?
Yes,
Read
sir.
this line.
Sir, it is read as sine inverse x or arc sine x.
Jasli Raj, can you read this last line?
So read as sine inverse x or arc sine x.
Yes, Johnson.
It is read
Can you
as
read this
sine
one?
inverse x or arc sin x.
Okay, thank you. Johnson Pritika, can you read this line?
It is read as sine inverse x or arc sine x. Sir.
Very good, Pritika. This one, Ashwara, can you read this one? And this one, Yashwantram. Can you read this line? Last line. Krupal,
Yes,
my
sir.
dear Krupal,
Sure.
can you read this line last time?
Sure. Sine inverse x or arc sine x, sir.
Arc sine x, very good. All of you remember this point. How to read this note. All of you learn this point, how to read the notation. What is the principal branch of sine inverse x? What is the principal branch of sine inverse x? Can you tell me, Joseph?
Sir, can you
Joseph?
repeat, sir?
is said to be principal value branch x? What is called principal branch of sine inverse x? On the screen itself, on there. On the screen itself, there for to my set. Which is said to be principal value branch of sine inverse x?
Sir, pi by 2, sorry, minus pi by 2 by pi by 2, sir.
It's very good. Level minus pi by 2 come up.
Sir, it's minus pi by 2, comma pi by 2, sir.
Sir,
What is the principal value branch of sine?
sir, your voice is not clear, sir.